Okay, so we are talking about regular expression. In the last class we have defined the regular expression. So, just to recap, so phi is a regular expression which is denoting the language, the empty set. Epsilon is a regular expression which is denoting the language, the singleton set epsilon, and A, which is coming from the alphabet, A is an alphabet, is a regular expression. For every alphabet is a regular expression which is denoting the language, the singleton set A. Okay. So, this is the way we define the regular expression for these notations, and then we are recursively going to define the regular expression, like if this is we called as base, then we recursively define the regular expression, like if R and S two regular expressions like R and S could be any one of this. So far we have only base case, then R plus S will denote the regular expression by three operator plus, concatenation, and star. So, by these three operations, concatenation and star, we will define the regular expression. Okay, if R is a regular expression, if R is denoting the language L of R and S is a regular expression which is denoting the language L of S, now R plus S is a regular expression. This is plus, we are using three notations, three operator, and the language of this regular expression R plus S is nothing but language of R union of language of S. This we defined in the last class. And then another two is R concatenate S. R S is also a regular expression. Now, what is the language of R S? It is language of R concatenate with the language of S. We know the concatenate operation. This is the set of all x y such that x string is coming from this and y string is coming from this. Okay. So, this is one recursive definition, 2, and then 3 is R star. R star is also a regular expression and the language corresponding to this is like this. Okay. And this is the union of for I is 0 to infinity. So, this is the way we have seen we can define the regular expression. Now, today we will mainly talk about some examples and some properties of this operator, this plus, concatenation and star, I mean the algebra of this operator. So, before that let us just quickly talk about some examples. So, regular expression is corresponding to a language. So, 0 plus 1 star. Okay, what is the 0? 0 is representing the 0 set, I mean 0 just the singleton set, 1 set. Now, 0 plus 1, if the sigma is say 0 1, then 0 plus 1 will represent the sigma, which is nothing but sigma. Now, 0 plus 1 star is basically the sigma star, that is the set of all possible string. Set of all possible string including 1, including the empty string. including epsilon, the empty string, that is denoting by this. Okay. Now, if we have a say regular expression like this 0 plus 1 star 0 0, this is also a regular expression. Now, what is the language corresponding to this regular expression? The language, if this is R, the language is nothing but x 0 0. Because this could be epsilon also or could be any other string. So, this is the language which is corresponding to the set of all string which is ending with the 0 0. Okay. Now, then we have defined the precedence of this operator, precedence of the operators. Operators means we have 3 operators plus concatenation and star. This is the 3 operator we are using to define the regular expression. Now, among these the star is having higher precedence than the plus than the concatenation than the plus. So, star is having higher precedence than the concatenation and also than the plus. So, this is the greater than means this is the precedence wise greater than, it is not the real number greater than. Okay. This star is having higher precedence than the concatenation than the plus, and the concatenation is having higher precedence than the plus. So, plus is having the least precedence. Okay. So, if we follow this rule the convention, then this we can denote by this is say 1 star, this is the first one we want, then we want to operate with 0 concatenation, then 0. Now, this may be, if we know this precedence, this may be written as, because this is same as 1 star, we want 0 then 0 then plus 1, simplify, we do not need the brackets once we know the precedence. So, what is the language corresponding to this? The language corresponding to this is R 1, this is R 2. So, union of these 2. So, this will corresponding to 1, and again R 2 R 1 we can write as product like 0 and this the concatenation. So, this is corresponding to 0 and this is corresponding to epsilon 1 1 1 like this set. So, once we concatenate this, so this will be any string with not any string, it is basically 0 then 0 1 then 0 1 1 like this, and you are unioning with 1. So, this is nothing but 0 1 0 1 1 like this. So, this is this type of string will appear in this. Okay. So, we can have some more example before we go to the algebra of this operator. Okay, we know this is 1 star 0 0 star 1 star 2 star. If sigma is say 0 1 2, what is this is a regular expression. If we have only 0 star 1 star say, then what is the regular, this is any number of zeros followed by any number of ones. Okay. So, this is any number of zeros followed by any number of 1. If we take a 2 star also, any number of zeros followed by any number of 1, this is a set of, the language is the set of all string with any number of zeros followed by any number of ones followed by any number of twos dot dot dot. Okay. So, any such string will come here. Okay. So, then we can have something with epsilon 0 plus epsilon. What is this language? This language is, this is 0, this is epsilon. So, this is nothing but 0 and epsilon. Yeah, 0 and yeah, epsilon we can write in this way, depending, I mean, yeah, so that we should not mix epsilon with this sigma. Sigma is the set of alphabet and epsilon is the null string. Null string is denoted by epsilon, we know. So, anyway, I mean, so this is epsilon, this is this set. Okay. So, this is this language. Now, if you take another language, say 1 plus 1 0 star along with this. So, this is, we can take 0 or epsilon from here, 0 or epsilon. So, this is nothing but 0 or epsilon, and here what it will come? Now, inside it, it is 1 and 0 1. So, then the star means we have all combination of these two. So, this is the set of all string that does not have two consecutive zeros. So, this is the set of all string not having two consecutive zeros, not having two consecutive zeros. Okay. So, this is the way we can have some more example on this. Now, we will talk about the algebra of this operator, like how to simplify this, like algebraic law. Algebraic laws of the regular expressions operators. Okay. So, what type of algebra we can, I mean, what type of algebraic law we can have? So, first one is the commutative, I mean the union is commutative. We have three operators. This operator means we have three operators, plus, concatenation and star. Okay, plus is the union operator. So, now plus is commutative. Commutativity of plus or union. So, what is that? That is basically if we have two regular language R, the R plus S is also regular language, which is same as S plus R. So, they are abelian. What is the proof? Proof is straightforward, because this is, so they are same means when we say two regular expression are same, if they are giving the same language, because everything in terms of language. We are only concerned about the language which it is accepting, I mean which it is representing, because regular expression is a form to represent a set of language. Okay. I mean easier way to represent a regular language, and these tools we are just algebraic law, we are just learning now to have the more simplification. If we have these laws, then we can use this law to simplify a bigger regular expression, try to simplify in a smaller way. So, that is the idea. So, this is okay, because this will corresponding to this is L of R, the language, this is L of S, this is L of S, this is L of R. Now, these two are union. So, the language L of this is union of this. Now, union is commutative, because if we know, if we have two set R and S, R union S is S union R. So, union is commutative, because union is just a set, I mean this is just a set, so that we should cover all, I mean this is set of all x such that x is in R or x is in S. So, it does not matter which order they are coming, I mean first we are taking from R or first we are taking from, because that is the union. So, this is commutative under union, this is the first law. So, R plus S is equal to S plus R. Yeah, for example, if we have say 0 plus 1, we can, this is a regular expression, we can write as 1 plus 0, both are same. Or if we have 0 1 star plus 1, this is a regular expression, we can write as 1 plus 0 1 star, either one of this way. Okay. Okay, now we will check the associativity of this plus. Associativity. Associativity means, so if we have three regular expression R, S, T, then say R plus S plus T is it same as R plus S plus T. Okay. So, this is the meaning of associativity. This is also true, because this is nothing but any one of these, nothing but the language, corresponding language is L of R union L of S union L of T. So, it does not matter which way we should take, we should first take the union of these two, then union of these three, or we should take union of these two, then union of these three. Okay. It does not really matter, because this is union itself is a associativity property is there. Okay. So, it is associativity is there. Then the third property is associativity in plus or in union. Now, we will check whether this is associativity there or for concatenation is also, because plus and okay, associativity for concatenation. So, that means, so if you have three regular expression, we want to check R S then T whether this is same as R S T. Okay. This is the meaning of, if this is true for all such regular expression. So, when we say two regular expression is same, if they are representing the same language, because everything in terms of the language. Okay. Now, what is the language corresponding to this? So, language corresponding to this is set of all x y, and we have a T. So, set of x y z, where x is coming from R, y is coming from S, and z is coming from T. I mean L of that, sorry, L of that. Okay, this is the concatenation operation. So, now it does not matter whether you read this x y then z or x or y z then x. So, they are same, because they are basically the x y z, and here also we have x y z. So, these are same. So, this is associativity is there for concatenation, but the commutativity is not there for concatenation, that we will check. So, we will check whether this this is the fourth property is concatenation is commutative. That means, if we have two regular expression R and S, then its R S equal to S R. This is the concatenation operation. That means, if the language corresponding to R S is same as language corresponding to S R. So, what do you think? No. Why? Because, so we can take a very small example. Suppose R is 0, S is 1. So, what is L of R? L of R is just 0 and L of S is the singleton set 1. Now, what is the language corresponding to R S? This is the x y. The definition is x y, x is coming from R, L of R, and y is coming from L of S. So, this is nothing but only one set 0 and 1, because there is only one element. And what is language of S R? This is 1 0. So, these two are not same, which is not same as, so it is not same. So, it is not same in general. Okay. So, this is not commutative. So, this concatenation is not commutative. Okay. Now, we will take some more example. Okay, so, phi plus r is same as r plus phi. Anyway, plus is commutative we know, but only thing we need to show phi plus r is r. How to show this? This is also easy, because what is the language corresponding to this? It is this union this. Now, what is this? This is phi union L of r. This is basically L of r, which is same as the language corresponding to r. So, this is another property which is straightforward. Now, 6 epsilon r is same as, here it is, we can write r epsilon is equal to r. How to check this? This is also easy to check, because this is nothing but this is corresponding to epsilon and this is corresponding to L of r. Now, what is the product? Concatenation. Concatenation is basically, so L of epsilon r is nothing but so set of all string x y, where x is coming from this set L of epsilon and y is coming from L of r. Now, L of epsilon is only epsilon. So, if you add with epsilon, epsilon is nothing, it is just a symbol, it is a string of length 0, it does not exist. I mean, so this is same as y basically, y, where y belongs to L of r. So, this is nothing but L of r. Okay. So, epsilon r is basically r over here, but in the plus, for concatenation it is true, but for plus it is not true. Why? For the plus, so this is 7, epsilon plus r is not same as r, unless L of r contain epsilon. If L of r, if epsilon does not belongs to L of r, then these two set are not same. Okay. So, but for concatenation it is okay. Okay, now we talk about distributive law. distributed law. Okay, so this is telling R, this is the left distributed law, R plus S into T is equal to R S plus R T. Okay. So, this is also we can easily verify, because the what is the language corresponding to this? The language corresponding to this is x y, where x is coming from L of R and y is coming from L of S plus this. Okay. Now, this is same as y is coming from either this or y is coming from L of t. So, that means this set we can write as x x t 1, where x is coming from L of R and t 1 is coming from t 1 is coming from L of t, L of S, sorry, L of S union of x t 2, where x is coming from L of R and t 2 is coming from L of t. So, that means this is same as language by R S union language of R T. So, then these two are same. Okay. These are the properties we require for the simplification purpose. Okay, then we have the more property which we will discuss in the next class. Thank you.